Did it capture it? Let's see. Okay, I don't think it captured it, so let's try that again. Get rid of that one. Yes, remove it, try it again. No. New window, capture. Okay, so will it capture on display capture? Okay, so it will capture display capture. I ain't at the pits. Okay, so I'm going to have to turn my display capture on and off. Let's give that a hotkey. So live stream minicam. Live stream small cam, that's the one we want, and that's going to be hotkey. On numpad 5, got it. And then the live scene. 5. Could be 2. 5 and 2. 5, got it, and 2, got it. Five, 2. All right, finally. Looks like today's gonna be an inception day, so let me get got a bunch of parts in, so let me get a case together and we can get a bunch of these parts put away. Alright, these can stay out. Those are out. Maybe. Gotta see what fits where. That just fits, so there's those. Throw these 2 bags away. I'll leave these in the bag for now. Alright, let's see if we got anything else down here. Let's see here. I think we could keep these in a bag. These are optical bump switches. Got 3 of the optical stop switches. We could put 3 of those in a bag together. PCBs, or perf boards actually. Okay, looks like we got a servo shield. Let's open that up. We'll be using this in a future project. Ooh, that's very nice. Looks like it handles 16 channels. I like that. I'm gonna put that back in, not the static bag, because we shouldn't be picking up no static. We're not gonna be shipping it right now, but I am gonna put it back in this bag, so we'll be able to order more if we like it. And let's continue on with the searching. Got an Arduino Mega. Some more proto boards. We got our fuses in. So now we'll be able to finish off our project for the inverter. 30 amp car fuses. See if these will fit in one of these smaller containers. Got them.
All
right.
Hey Scooby-Doo.
Hey, how's it going? We're doing some unboxing right now. Got a shipment in and we're actually looking for something, but I haven't found it yet. We got some TL072s. I think I have some of them in my smaller chest, so I'm gonna put them up there. How are you today, Red Hat? I got some more nozzles for my hot air station.
Read hot, tummy full.
Oh,
looks good.
I got some compound for attaching the thermal paste for the heat. I got some infrared encoders for sending. These are like what remotes use, like remote controls. You have the infrared sender and the infrared receivers, so we can send infrared signals from one board to another. Let me look at what else we have in here. We have, is that lasers? I'm not sure if that's lasers or not. I think those are laser lights. I'm not sure on that. I'm going to check that out. I think I'll put these and these in the container together because they really don't have no place to go. I'll put all of this into one box together there. These go up here, so let me put this away. I should have a little chest up here with, I have a little drawer. There it is, TL072s. TL072s. These could go together. Alright, let's see what else we got.
Read hot, looks like my old tackle boxes.
Yeah, it kind of is. These ones come apart. Can you see that? You could take the little deals out and rearrange them. And if you look
Read
at the
hot,
lid...
I had crafts in them.
Yeah, if you look at the lid's sorted so you can move these around to different positions. You can put all your big ones here and your little ones there, or however you want to mix and match them. You can twist and reformat them however you want. Alright, what else do we got? I need to get a light. Just a minute, let me get a light down here so I can see what I'm doing. Okay, looks like that's the majority of it. I did not find what I was looking for. So what I'm looking for must be in a different location somewhere. Where else might it be? I'll have to look somewhere else, I guess. Well, we could still move forward without it, but I was hoping to find it. Also got a nifty little screwdriver. You see that? It's got a really small tip on it. A whole bunch of little tips there. A whole bunch of little tips there. And it's a ratcheting screwdriver, so you flip it over. It ratchets one way, flip it over, it ratchets the other. Has a long extension you can put
Read
on
hot,
it.
sounds about right. LOL. LEBTV Live, hello.
Hello. So, got me a pretty good little kit set up here. Alright, so let me finish putting this away, then we can get started on... Okay, so what we're working on today... if you guys didn't catch the bottom of the stream down there, the solder station that we was working on the other day, I got it working to a point. So, whoops, I went and dropped one of my tips. Let me get that picked up. The point that I got it working at is it works fine if it's at room temperature. So let's say 80 degrees or warmer, you flip it on, works perfectly fine. Heats up, everything works 100%. If it's at 75 degrees or cooler, then it cycles just like it did in the first place. So my question was, what's causing it to do that? Upon further inspection, what I noted is the microprocessor, the brains, I guess you could say, of the operation. If it gets cool, that's what causes it the power cycle. So if you warm it up, you can warm it up with your finger, because your finger's technically above that temperature. So if you put your finger on it and warm it up, it'll warm up quickly and it works fine. Once when it warms up, the chip itself will stay warm enough that it works fine from that point on. But if you turn it off and let it get, again, below like 80 degrees and it cools off, then it'll power cycle again. So it's still not functioning to where it needs to be. So we have a couple options. Option one, we can try to replace the chip, which is really not feasible because although we can purchase a chip, they're only $3 or something on eBay. We can't program it. We could try to download the software. We can try to, you know, put a sketch on it, I guess you could say, and, you know, try to do that part. But I mean, the odds that we're going to actually be able to get all that done are slim to none. So that's really not a feasible operation. We can't get the original sketch from the company. I already contacted them. No response. Not that I was thinking it would be. It's a Chinese manufacturer, Japan, whatever. So wasn't planning on that anyway. Option 2, we can try to hotwire it, I guess you could say, and make it run basically like standalone. So it's just analog. You just turn it up and it just literally just cranks up to a certain degree.
Games, I know is late, but Manatico Games, Happy New Year.
Oh, absolutely.
Manatico Games, MA.
Nice seeing you. Hadn't seen you here in a while. So that would be option 2. It's just kind of like hotwire it. So it doesn't turn off. It's basically not a smart component. You just turn it up and turn it on, which is not good because it's a fire hazard. So we can't do that. So that takes away option 2. Option 3 is, I counted the pins on this, and this is a 20-pin chip. There's a 20-pin microcontroller. An Arduino.
Oh, by equals past the brain.
Yes. An Arduino, this is an Arduino. We mess with them all the time. An Arduino is a 28-pin chip.
Yeah, I had my friends at my house for New Year. Yeah.
6, 7, 8, 9, 10, 11, 12, 13, 14. 14 times 2, so it's a 28-pin chip. We can take an Arduino, and what we can do is we can try to take an Arduino, which is basically a kind of like a universal brain. You know, it's something that we can program. And we can basically try to make this do what this one's doing, even though this has 28 pins in it. And if we have enough of these pins on the Arduino available to take the place of the pins that this one's doing, the brain that's messed up, then what we can do is write a program on the Arduino that will do what this one's doing, the one that's messed up, and then replace the one that's messed up with the Arduino, and then make a conversion board out of what you had just seen. Where'd I put it? Here it is. Out of this proto board. So we'll put basically the Arduino here, and then put a whole row of wires down to, from the 28 pins down to the 20 pins, and then put a whole bunch of pins there. And then over here, we'll just put, there it is. We'll put the Arduino here, and then just have it convert the 28 pins over to the 20 pin chip. And just eliminate the brain altogether and just have the Arduino take the place of the other one. And the Arduino is a little bit more of an expensive chip. It's like a $4 chip, but I mean still it's a whole lot cheaper than replacing the entire unit, because in reality the entire unit's fine. Everything else I got working. The transformer's working. Everything else in this is working. The only thing that's malfunctioning is the $4 chip. Well, the $2 chip. And so there's no reason why everything else shouldn't be working on it, you know. So they're both 5 volt compatible. This chip, the old brain, is 5 volt compatible, and the Arduino is 5 volt compatible. So if they both have enough GIO, then we ought to be able to do this. So the only problem is we need to find out what every single pin on this one is doing, figure out what its purpose is, and then program the new chip to do what this chip's job is. So it is a large process, but at the same time, it'd be a good learning experience. And if anybody else had the same problem with one of these, then they'd be able to more or less redesign theirs the same way. Because, I mean, you know, if it happens to one, it's going to happen to another. And so, I mean, you know, it's a good learning experience. And so I figured that would be what we're working on today. So, so first of all, we can see what happens with a cold startup on this. Now, I haven't been touching the chip for a reason. I think my room's cold enough that the chip should malfunction, basically. So if I haven't been touching it and the room is cold enough, I think it is, then if I turn this on, the number should just kind of blink and it'll try to turn on, but it won't really function. So let's see what happens here. Let me turn my light away. So there we go. So watch what the numbers do. Now what should happen is the numbers should blink once or twice, and then the bottom number should give a temperature, and then it should start climbing because it's just like an oven. It should just start climbing because it starts reaching like 400 degrees. But if it malfunctions, then it'll just keep blinking and turning off and turning on like like it's power cycling. So let's see what happens. Turning it on now. And now you see that shouldn't happen. Now it's power cycling. And it's trying to turn on again. And there's the failure. See, it's failed again. Now it tried to turn on again and it failed. And it tried to turn on again and it failed. And now I'm turning it off. Now, before I go any further, I'm going to hop over to my stream.
Tech.
Yes. Doing a lot of tech this, well, I've been doing a lot of tech for a while. I'm going to do a clip, so just a minute, guys. I'm going to put a marker on my page so I can be able to clip this later. Go to my dashboard, and I'm going to drop a marker in. All right, I'm going to put in fail, F-A-I-L. Add a marker. Okay, so I'm going to do this again. Here's the failure. Now all the knobs are up. And it's just going to keep cycling. Get a little bit better view maybe.
Fusion, how's it going, bro?
It's going great.
Good to see you. Good track in the background.
Thank you. Okay, so this is what it looks like when it's failing. It just keeps power cycling. Now all I'm going to do is I'm going to place my finger. I'm going to mark this again. I'm going to put warm up. And mark it again. And open this back up. I'm going to put my finger on the chip and just allow it to warm up. Now, all I'm using is my finger temperature. It's going to take it a minute because, you know, my finger isn't just burning up hot. There's the temperature. Now, see, it's getting warmer, so it's starting to function a little bit better as my finger's warming it up. See, this light's trying to kick on now. I'm switching fingers because my finger's actually getting cold. It's getting a little bit closer. Now, I'm going to cut the music off. You listen, you can hear the fan trying to kick on. Switching fingers again. Now that's 150 degrees Celsius, 180. Switching fingers again. And that's it. It's running 100%. Now, just for the scene, I'm going to show you guys something else. I'll show you how well this little machine's working. I'm going to start kicking my lights off, so just give me a second here. I'm going to remove my finger now because it should be warmed up by now. Alright. I'm going to turn my other light off. This is how hot the iron's getting. You all ready? That's glowing red. Now I'm turning it off. I just turned the heat down, so now it should start cooling off. You can see the temperature's dropping.
Fusion looks purple.
And now it's cool. I'll turn the lights back on. And that's it. It's working 100% as soon as you warm it up. Yeah, it does look a bit purple. Probably my camera. I haven't color corrected my camera or nothing. Let me see. This is blue, so that is showing up blue. This is green. So it isn't too far off, but when I turn the lights out, the camera, it's actually showing up in the camera a whole lot brighter than it's showing up on my actual eye. So the camera's probably color correcting. Let me turn the music back on now. So this is what it's doing. When the chip gets cold, it fails to function. And I mean, like, I could put alcohol in the chip with a cotton swab or compressed air or anything like that to cool the chip off. And if I do that, then the chip no longer functions. As soon as it gets cold, the chip functions. Nothing else, no other component am I messing with. And so it has to be the chip. The chip itself has just failed. And I've considered a couple other options. I've also considered putting a resistor back there to just warm the chip up, which is an option. But, I mean, what's to say that the chip won't fail in a week from now or something? So I decided to try to use an Arduino to fix it. Alright, let me see here. Configure video. Alright, so let me flip this off. So how are we going to do this? Well, the unit has to be on in order to figure out what everything does. So I can turn the air all the way down. I can turn the heat and the soldering iron all the way down. I'm going to put the soldering iron into my soldering iron holder right here so it won't burn nothing. And we're going to go old school with this. So, let me see if I can find another camera. Turn on the oscilloscope so it can warm up. Okay. All right, just a second. Let me see if I could do anything with this one. I'm warming the chip back up because it's cooling off. I'm actually using the soldering iron to warm itself up. Okay, it's good and warm.
The _SWK, what's wrong with this thing, MD?
The microprocessor. If the microprocessor gets cold, then it begins to cycle and fail. Cold as in below 80 degrees. Apparently 80 degrees is the failure temperature on this microprocessor right here. At 80 degrees, it runs out and functions perfectly fine. At about 78 degrees, it begins to power cycle and fail, and anything below that, it pretty much just power cycles completely. It will not even turn on. So we can't really change out the microprocessor for another one of its kind. Because we can get another one, that's not a problem, but we can't program another one like it. It's a Samsung, and even if we could, we don't really have the ability to program it. We don't have a sketch or a program to put in it because it's proprietary. They don't want to give it to you. So it looks like we're going to try to change this out with an Arduino. Or that's what I'm thinking anyway. So in order to do that, I got to reverse engineer it, see what all the pins are doing, and then go from there. So right now I'm trying to set me up a camera so you guys can view the scope and on one camera, and then see what I'm doing on the other camera. I really don't have nothing set up for that, so I'm kind of just messing around over here trying to get it. Problem is if I set the scope up close where I can set it up real nice, then it's all blurry. Oh, I think I got it. There we go. Now I got that there. Alright, let's try that. That looks a little bit better. So now you can see the scope printout. Let's put this at, let's see, it's at 2 volts per division. So that'd be 2. We need it for 5 volts all the way up to there. That'd be 1 volt, so 1 volt per division. Alright. Now, if I can do this without bumping anything, I think we'll be alright. Alright, so we got that in place. Let's see if we go here, which should be ground. And here, okay, that's ground right there, and this should be 5 volt. Yep, that's 5 volt right there. Okay, so let's adjust this down a little bit. Okay, so that's 1.5 volts per division. So that should be good right there. Alright, so we got our ground and we have our 5 volt rail and our ground. So now what we're going to do is get us a notebook. Told you we're going old school. Gotta warm the chip up again. We're gonna have to do that periodically over and over again. Oh, let's see, SWK. Not SWK, SciFusion. If you'd like to request a song, you can feel free to. You type in exclamation point SR and type in the name of your song, and it'll try its best to match it. Or you could type in SR and put the link to a YouTube. song and it'll put it on there. There's certain limitations, but for the most part, you can
Sci-Fusion,
put most of them on there.
promises Calvin Harris.
There you go. Something like that.
Sci-Fusion.
So, song requests are running, or they should be running if it isn't busted or anything. Alright, so we got us a piece of paper. Let's move all this stuff out of our way. We'll put it over here by the scope. We don't lose it. It's going to be a tedious process here, guys, but we're going to work through it, or try to. Okay, so the first thing we need to try to locate is our knobs if we can. I don't want that over there where it can get burnt. Alright, so we're going to have, which way is this chip? The chip's number 1 pin is over here. So we're going to have okay, nothing moved. Good. Alright, so we're gonna have this right here. That guy in that song needs a cough drop.
Now to judge what I'm doing. Are you high enough to skills that I'm ruined? 'Cause I'm ruined.
Okay, so we already know we need a positive here and a negative here. And this is pin 1 and this is pin 20. Alright. And all of that was off screen. There. If I get that on screen, then this is off screen. Let me see if I shoot it at this angle. There we go. That's a little bit better. Alright, so let's check what is going on with... Okay, it's still working. So what is going on with pin 2? Okay, so we have a pulse wave. And does it change with any knob changes? Okay, it's changing with the soldering temperature. Okay, let me warm the chip back up. Alright, put it back down. Alright, so back to pin 2. Let me see if I can adjust this a little bit better here.
I made no promises. I can't do golden rings, but I'll give you everything. Magic is in the air. There ain't no science here, so come get your everything. I made no promises. I can't do golden rings, but I'll give you everything. Magic is in the air. There ain't no science here, so come get your everything. Tonight.
Alright, let me see what's going on here. Menu. Channel 2, that's the problem. We need it on channel 1. Alright, so let's look at these pulses. As I turn up the soldering temperature and turn down the soldering temperature, the pulses change.
Fusion, oh Jebus skip this song.
Oh, okay. Alright, so this reacts with, I think, every single knob.
Fusion, thank you LOL. Copyright-less songs. XD I've used these on my tutorial videos.
Yes, every song on here should be copyrightless. Okay, so unknown on pin 2 so far. Let's try pin 3. We'll do hot air. Okay, we're getting the exact same response. Not on the air though. The air does not change pin 3. The hot air temperature knob changes it, and the solder temperature knob changes it. So I'm thinking, so far I'm thinking pin 2 and pin 3 has to do with the readouts. Let's go with pin 4. No change with the soldering temperature. No change with the hot air temperature. No change with the air temperature. Turning on the soldering station. Trying again. No change with anything. Turning the manual switch on. Turning the manual switch off. On again. Gonna heat up the chip. Still no change in pin 4. So far that just looks like a steady clock cycle. Very small though. So far we're bust on 4 pins. Pin 5. PWM changes on both of the temperatures. Pin 6. Nothing on either temperature. Nothing on the fan. Nothing on the manual. Nothing on either switch. It's just a high pin. Pin 7. Hot air on. Just a high pin. Pin 8. Pin 8 is the hot air switch high and low. Okay, so pin 8 is the hot air station on or off pin. So we can mark that one down. Pin 8 is the hot air station on or off. One, 2, 3, 4, 5, 6, 7, 8. Now the question is that connected to the switch? So is that on and off from the switch to the microcontroller, or is that on or off from the microcontroller to the circuit? That's what we don't know yet. So is that in or out? So we don't know if that's an in or an out pin yet on pin 8, but we do know that that's on and off. Because when we turn it off, then it goes high, and when we turn it on, then it goes low. So off is high and on is low. So off is high. Heat up the microcontroller again. Let me double check that. That's pin 8. So low is on. Low equals on. Got it. So now let's go to pin 9. Ooh, look at that. That's odd. Ah, that's it. The ground clip came off. Thought something wasn't right. Okay, let's try that again now. Pin 9. Okay, that's high. Okay, that's the soldering station. Okay, up is, let's see, high is off. The pin 9 is soldering station. On and off. Oh, and all right. IO. I don't know if it's in or out. And low is on. Alright, and then we got pin 10. Last pin on this side.
The underscore SWK, can you ID that microcontroller?
I can. Okay, so pin 10 is the manual switch.
The underscore SWK, it might be a common one. You can just rip the firmware from and replace LOL.
I can't even find a... I can give you the number. It is a... Just a second, I'm going to have to move the camera. What did I do with my light? There we go. Are you ready? It's an S as in Sam, 3 F as in Foxtrot, 9 4 C as in Charlie, 3 E as in Echo, Z as in Zebra, Z as in Zebra, dash, D as in Dakota, K as in Kilo, 9 4. And I'm pretty sure I looked it up and it was a Samsung device. I couldn't even find a programming software for it. Let me swing it back over. I did find that you can buy them on eBay for like $2. So purchasing them's not a problem. But I don't know how somebody would program it. I'm warming it back up now.
The underscore SWK, S3F9454BZZDK94, that one?
I believe that's right. They're on eBay for like $250. I think you get 2 of them. Alright, it's warmed up. Alright, so that last one was the manual and auto switch. Let Let me readjust this here. But if you find a link or something where we can download, you know, I mean, where we can rip the software, I'm game to try. But right now, I think our only option is the only thing that I think we're going to have problems with doing it this way, with replacing it with an Arduino, is the readouts. I don't know if we're going to be able to connect to these readouts or not, because Arduino and readouts, I mean, unless you have a specific driver you're connecting to, that's a hard thing, for at least for me it is. I have bad luck with readouts. Okay, so we're working on pin 10. 1 0 equals. Let me go over here and we'll go to pin 10. Now I gotta have a hard time getting to the pins on the other side of this chip. Alright, so pin 10, let me get my readouts on that again. Alright, so manual is high and auto is low.
The _SWK, AHHE's a Zillig, you can use those tools on it.
Really? Auto manual switch. IO. What was it? Low? High is manual and auto is low. So you can pull data off of the chip with them tools? ISY. Let me see. You can pull data with I'm not familiar with either one of those. Well, that can't be right. Let me look again.
You like to Arduino.
Yeah, I do. I mess with Arduino quite a bit. Okay, so let's see. So can you pull data off of the chip with those tools, SWK? I'm not familiar with those tools, either one of them. Let me warm this back up.
The _SWK, that's what I'm looking to see.
Oh, okay. Because I know even with like Arduino, it's hard to pull data off of the chip. Well,
the _SWK, Zillig is like an older, harder to use version of the Arduino.
Okay, because I know even with like Arduino, I mean, you could pull, let's see, what can you pull? You could pull machine code off of an Arduino, but transferring the machine code back into an Arduino sketch is, I mean, it comes out, but it's kind of garbly gooped.
The _SWK, yeah, that's all you really need.
Yeah, that's true, because you could just technically copy the machine code back over to machine code. I mean, you don't really need to know what it's doing. You just need to have it do it over again, really, I guess. Okay, so let's check out
the _SWK. You don't need to decompile it. You just need to dump the flash and reload it.
Right, that is true. Alright, so let's go with pin 9, because I can happen to reach it easiest without shorting everything out, I hope. There.
Side
Okay.
Fusion, SRMK17.
Alright, you got one. Okay, so it is high right now. It's just plain high. Nothing's changing anything.
The _SWK. Can I post a link later?
You should be able to. If you can't, I'll permit it here in a second. Alright, so that's all good. Okay, so we have
the _SWK, under Tools and Software. The _SWK, looks like it let me.
good deal. Okay, so with it on auto, again I am on, come on, stay on there. Okay, I'm on pin 19. I'm gonna lift the, okay, so here we go. That's the output. Pin 19 is the output for the that's what it is. It's the output for the switching mechanism for the heating element, the driving element for the what do you call it? The hot air. Now, is it the heating element or the blower? Let's find out. Okay, that would be the fan. No. Yes, that would be the fan. So pin 19 would be the fan for the blower. Pin 19's the fan. 19. And it is high on or high off? High is off, low is on. All right, let me look at your link. Sorry, it took me a second to get there. Alright, so let's see. Zilog is a trusted supplier of application-specific embedded systems on chip or system-on-a-chip solutions for the industrial customer markets. see their software here. So where is their programmers at? Okay, so let's flip this over here just a second. Okay, I'll take a look at this after I'm done checking these pinouts. Okay, let me keep going here. So we have pin 19 is the fan output. When it goes low, the fan is on. Uh-oh, gotta heat the chip back up.
The _SWK, loose connection in the chip LOL.
Yeah, that's what it is. I think one of the bonding wires are coming loose.
The _SWK, cut the top off it and do some micro miniature repair.
Oh, I know, huh? Decap it. See how hot it is. Well, you see, I was thinking about just taking like a 1 watt resistor and soldering it from here to the ground and just laying that ceramic resistor right on top so it just stays warm all the time. But I thought, well, eventually that chip's going to fail anyway, even with the resistor on there. So now this is, do you know the viewer, that's your
the
fan?
The _SWK, yeah.
You know the viewer, that's your fan, right? He watches the stream all the time. Okay, now I'm having a hard time seeing. I'm gonna have to do something else with this now.
The _SWK, I don't think I have chatted with him.
Okay, well, he's in my stream quite often. He's probably working today, but he's in my stream quite often. Anyway, this is his box. This is his unit. He bought it brand new from Amazon. He plugged it in and it exploded. He heard a loud pop. And so I don't know exactly why he didn't send it back in, but anyway, he didn't send it back in, and I think he ended up buying him another one or a different one, or I don't know, maybe they refunded him and he got another one. Anyway, he got another one, so he sent this one in to me. And so I replaced the capacitor that blew up on it, but I think when the capacitor blew, it sent a surge to the chip, and that's what caused the chip to mess up. So I replaced the capacitor that blew up, which is what happened. A surface mount capacitor gave up its life, and so I replaced that, but now I found out that the microprocessor's given up its life, so that's where I'm at now. Alright, let me see here. I'm on pin, let's see, that was 19. So now we should be on 18. 18 is nothing right now. Okay, so up, down, nothing there. Up, down, nothing there. Up, down, nothing there. On, off, off, on. Everything on. So let's see if this is the heating element for the
underscore SWK. The underscore SWK, data sheet for UMD.
Okay. Okay, so it doesn't look like this pin does much of anything, at least not that I can tell. Okay, so unknown. Going to the next pin. Okay, it's high. Nothing there. Oh, I missed something. What was it? Hey, line up. Thank you for the follow, man. Haven't heard anybody in the chat. Did you say something and I missed it? If so, I apologize. Alright, so hot air doesn't cause it to go on. Oh, there we go. So it turns on with the hot air. So is it the temperature for the hot air? Okay, so we need to figure out what in the hot air circuit is causing it to go on and off. And which pin was we on? We was on... Okay. Okay. So with it turned down, not seeing anything. So is that just a switch in and out? No, that's not just a power switch. That could be the input from the manual and auto. So let's call that the manual auto possible in and out. There's a delay though. Is there a delay in the meter, or is it a delay in the... Is that the light?
Psy Fusion, SR party favor, in my head. Psy Fusion, is that an IRC bot? Psy Fusion, or MIRC?
It's just the Streamlabs chatbot.
Psy Fusion, gotcha.
Alright, so where was I again? Was I here? Let's turn the temperature up. Now let's turn it down. Okay, so it's definitely not the switch.
The underscore SWK, oh look Pinouts, so you can see what is hard to find pins.
Okay. So this definitely has something to do with the actual heating element. It is 20, 19, 18, that's 17. So that definitely has something to do with the hot air. 17 does. Mark it down. 19, 18, 17. 1, 7. And that is hot air. I don't know if that would be the fan on and off, or let me think a second. I'm going to call it fan. Fan out.
The underscore
and
SWK, according to the pinout, that could be an analog input like maybe temp.
Okay. It is high off. So when it is high, it's off. High off. Okay. Oh, you know what that could be? Let me see. I need to warm the thing up again. Warm up, warm up, warm up, chip. That could be because I got a Hall effect sensor in here too. So I need to find that also.
SWK, pins 11 to 18 are all ADC capable. Ping 13 is PWM capable, and pings 18 and 19 are I2C capable.
Okay. Okay, it's on auto now. So let me go back to go rotate this. And you said pins 11 to 18. I'm in 17 now. So let's go to 17. That could be a Hall effect sensor. Don't know yet though. Alright, so let's go to 16. Okay, let me write that down. A possible Hall effect sensor on 617. Alright, so maybe a Hall effect sensor. Move this back over this way so I can get back into the range. Gotta be careful, this thing. Gotta remember I'm dealing with heat here. Alright. So where was I? That was 17. Let's see. 20, 19, 18, 17, 16. We're back over to 16 now. Okay, on pin 16. We are low. No change in anything there. Nothing there. Nothing there. Nothing there. Nothing there. Okay.
The underscore SWK, O pin 1 is VSS and pin 20 is VDD.
Okay, those ones I did find right then. I thought that's the way I wrote them down. Alright, you. Where was I? 20, 19, 18, 17, 16, 15. Okay, that seems to be cycling. See, now it's low, and it should start cycling here right about now. Yes. Okay, so that's the heating element for the soldering iron. That is pin 16. Okay, and let me see which way it is here. Up is off. High is off. That's pin 16. That's pin 16, 1, 6. High equals off. Alright, high equals off, and that is the soldering iron element.
Fusion, leaving soon. Good to see you.
Oh, good to see you too. Are you going to be streaming soon? Are you going to be streaming anytime soon, Fusion? And if so, what are you going to be streaming?
Fusion, as soon as basement gets warmer, LOL.
Oh, okay. Warm up the chip again. Alright.
Fusion, probably the same stuff. Websites, IT. I am considering gaming, but I suck at interacting while gaming.
I understand that, but hey, practice makes perfect, so keep practicing, you'll get there. Let me put this down this way so you can just see what I'm doing. Ain't no sense just having a camera sitting there doing nothing. Let me put this back over here so I can see what I'm doing. And
Fusion, thanks, take care.
For sure. Can't wait to see you streaming again. Been missing you. Alright, so 20, 19, 18, 17, 16. I think I got that wrong. Let me check this one right here again. Yep, that was 15 that I have. Let me mark this one out. 15 is the element. Alright, so we got 15. Let me double check that. 20, 19, 18, 17, 16, 15. Fifteen's high. I turn the element on and it goes low. Low is on, so that's correct. So now let's go to 14. Turning it on. Nothing on the hot air. Nothing on the element. Turning them both on. Nothing on the auto. Nothing on, oop, there it is. There's the knob. Okay, so I'm on 14, and that is the hot air temperature control knob. And that's the only thing it controls. So 14, let me turn it off. Yeah, that's the only thing it controls. 14 is the hot air temperature control knob. And that is on, let's see, that'd be 10, 11, 12, 13, 14. 14 is the hot air temperature knob. 0 equals 0. And now we're going down to, let's see, 11, 12, 13. So I'm assuming these next ones should be the control knobs. Yep. Next one is the soldering iron temp knob. Eleven, 12. Okay, don't know what 12 is yet. Okay, it's ramping up slowly. Try that again. There it is. Okay, so that is the iron thermocouple. 0, 0.
I'll take us back to times when lives were similar and times that all seemed easier. Don't be afraid, I'll be the one to guide you through this endless maze.
Okay, let's turn the iron all the way up. And let's see what 480 checks out to be, so we can map it. And that was 12? Yep, that was 12. Okay, it's at temp. So all the way up. 2.4 volts. .4 volts. And that equals 480. And that'll be our map for that one. And then we got pin 11. Okay, that's the hot air switch is turning that on and off. The auto manual is turning that on and off. Okay, that is the heating element for the hot air station. High is off. Okay, high is off. Now I need to find what the rest of these pins are for. High is off. Okay, 11 is hot air, heating element. Okay, so let's go look at numbers 18 again. Okay, we didn't have 18 marked, but I think we can mark that as the Hall effect sensor. So that's our Hall effect sensor is 18. Yep, that's our Hall effect sensor.
It's got me thinking about us more. It's these bright lights, they put me in a daze, and I can't stop but think about the way that you move around up and down on that stage. It's your future vibes.
All right, and it is low is in the saddle and high is out of the saddle. All right, so now we got pins 2, 3, 4, 5, 6, 7, and wait, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6. Okay, I was just off by 1. That's what's wrong. Okay. So we got pins 2, 3, 4, 5, 6, and 7 to figure out. Back to the top side of the board. So we need to find... We still have not found the air controller, which it may not be going to the microcontroller. It might just have that running to just straight to the circuit board, so that might be why we haven't found it yet. We have not found the temperature sensor coming from the hot-air station. Again, that might not be coming to the microprocessor. So let's go back and check these top pins up here. Let's go back to 2, which I believe most of these up top is going to be for the digital display, so I don't think we're going to get very far with this, but we're going to double check it anyway. Let's go back to 2. Oh, we're power cycling. So we got most of this chip figured out. Only thing we got left is these top pins up here. Okay, there's 2. Let's back this out a bit. Yeah, that looks like serial data to me. I mean, digital data to me.
I left my doubts when I was swept by the ocean, and every pulse from the tide was a finish line.
Let me see what I can do with that. Let me see here. It's been a long time since I messed with this, so let me look at this a minute. Display, is that what I'm looking for? Grid, no. Math.
skies that left my mind, they were your design. I followed roads I won't
Okay, let's see if we get anything that way.
lead me to your side. There is a burning in the clouds. Take a deep breath in and step out from the
Okay, so it is not hexadecimal.
feeling of realization in that I'm here.
Not decimal.
Loud and clear, when we get lost in our own minds, you'll be keeping me near.
Not ASCII. It's not line.
You'll be keeping me near. I hear you loud and clear. When we get lost in our own minds, you'll be keeping me near.
I try to cheat, but I won't be. Waste that line, you can take your time. Ready, set, go. Waste that
Okay, let's keep sweeping.
waste that line, you can take your time. Ready, set, go. Raise the time. Raise the time.
Nope, not. I'm not finding none of the standard. Not finding none of the standard codings on it. So math decode. Let's turn it off. All right, and let's turn math off. So let's clear it. All right, bring it back. All right, so now let's go back to pin 2. Nothing remarkable. In 3, again, same thing, data. Pin 4. Now this is an interesting little pin right here. I don't know what you're doing. You're very low signal. We're talking 800 millivolts. What are you doing, you little fella? You're a very inquisitive little guy. Let's turn stuff on and off and see what happens with you. You seem very noisy, you little pin. Are you just a noise clarifier? Feel like that's what you are. Bring you up some. Okay, so the pot's not going nowhere. Come on. This one's still a miss. Don't know what this is. Just a high pin. Maybe like a reset pin. Okay, I already got this one mapped. Let's see, that is, yeah, pin 8, 9, and 10. So those ones I got mapped. This one is 7. Betting 7's probably a reset pin. Let me look at the diagram that SWK sent me. Where did it go, SWK? Da 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 da. Pin 4 is the reset pin. Let me look at that. Pin 4. 1, 2, 3, 4. That one. Okay, that's the one I said was very interesting. That's the one I thought was a noise pin. Okay, so that's a reset pin. The other two are data in and out. Pin 7 is a P2? P2. So that's just a digital pin then, right? P2 is a digital. So then I don't know what pin 7 is. It doesn't seem to respond to anything unless it's a safety pin. Nope, not there. So let me mark down pin. Let me turn these off. It was pin 4 is a reset pin. And it goes low or high? Low, I think. 1, 2, 3, 4. It goes low. 1, 2, 3, 4. Alright, so that's a low pin, and that is reset. So now we lack pin 2 and 3, 5, 6, and 7. Now 2 and 3...
Read hot, too many keys LOL.
Too many keys, yeah. Okay, so 2 and 3, I'm pretty sure they're just using them for the digital displays, 2 and 3, because look at the signals that we got on them. So I think that's digital displays. That I'm pretty sure is a digital display. That's just a high pin. So digital, a high pin. So let's look at that one there. That was just high. Let's see. Let me look at that again. Digital, reset. Okay, here's how you know that's a display. Look, it's power cycling with the displays. When the displays go dark, then that is power cycling, so we know that's a display. Let me check the other one. That's not changing. Let me check these two. That's pin 2. See, that's a display pin, and then it should go out. There it is. Now let's check pin 3. That's a display, then it goes out. Display, then it goes out. Okay, so let's heat this back up. Turn the hot air on.
That underscore your underscore fan, so what's the Arduino gonna do?
Okay, so did you just get here, fan? I don't know how long you've been here.
That underscore your underscore fan, yes.
Okay, so...
Dapper King, I am new too.
Here's the thing. I found out, do you see this little chip right here? That's your microprocessor. What we found out is this. Everything works fine above 80 degrees. 80 degrees and above. In other words, room temperature of 80 degrees and above. Everything works fine.
That underscore your underscore fan. Scope covered it.
Okay, let me see if I move it here. There we go. This is your microprocessor. Everything at 80 degrees of room temperature and above, hot air station works 100%, 5x5, no issues whatsoever. At 78 degrees, it starts to cycle slightly, and if it gets below 75 degrees, it pretty much does the exact same thing. It does a complete shutdown and only power cycles. You can put your hand on the chip and warm it up with your finger, and once when it reaches, again, 80 degrees and above, it'll function and it stops functioning again. So what has happened is, just a second, I feel like I'm yelling. What's happened is inside the microchip there's bonding wires, and the bonding wires are like, I don't know, 1/100th the size of a human hair. And I think
that underscore your underscore fan, bad chip.
Yeah, what I think's happened is the bonding wires inside the chip, when the capacitor
Christina
blew,
Lopez,
it overloaded the... Oh, thank you.
Dinner at 6.
Okay, it overloaded the bonding wires inside the chip, and so the chip is intermittent. That means that once when it gets cold, for some reason, the laminations start to open up and the bonding wires separate, and that causes it to malfunction. Once when it heats up, the silicone expands enough that the bonding wires make contact contact and the chip functions perfectly properly. We can purchase a new chip, but to program the chip, you need their software, and then of course you need their code. Like an Arduino code, you need their proprietary code, and it's just going to be a headache to try to get all that. So what I did was I decided to take each pin of the microprocessor that they have, and I've scoped it out and tried to figure out what each pin does, which that's what I have here. I'm doing it old school, so excuse the handwriting and everything. I'm just jotting stuff down. So I've went through and I've probed every single thing one at a time. And I've wrote down what I've found so far every pin to do. Kind of cat scratch. And then what I'm thinking we'll do is take an Arduino and little by little rewrite an entire sketch onto an Arduino chip. And when we get it on an Arduino testing and working fine and on a simulator basically, we will take an Arduino chip, put it on a proto board similar to this one, and we'll proto board the Arduino chip, just the chip, not the whole circuit board, just an Arduino chip on a proto board. An Arduino has 28 legs on it, and we will just use the chip and wire it to basically an adapter to a 20 pin, and just plug the Arduino here and just have the Arduino chip just running right here in the background and remove their proprietary chip altogether. It's a Samsung chip, so I mean, I'm sure the chip was perfectly fine until the capacitor blew. So that's where we're at so far. I've gotten everything sketched out, with the exception of 1, 2, 3, 4, 5 pins. So 5 pins I've failed to figure out what they do. I have a pretty good assumption what 2 of the pins are.
_your_ fan. Poor chip.
I know. I mean, the chip I think did pretty good. It got a full 45 volts, 46 volts sent to it. So I mean,
_your_ fan. So we would have to reprogram a new chip?
Yes, absolutely. And like I said, if we bought a new chip, it would be, only a couple of dollars, but, then we'd have to get the software to reprogram it, which don't know whether we would get it or not. And I don't know if it would need a special programmer or not. So I don't even know, it might be $100-something just for a programmer to reprogram it. So I mean, it may not even be worth it to try. And then even if we did do that, we don't know what program they have on there. So we'd have to try to figure out how to reprogram it and everything. So I think
_your_ fan, KK.
I think it'd just be easier to try to make a new program from scratch from an Arduino. And they're both 5-volt chips, so that shouldn't be a problem. Everything coming out of the chip is 5 volts, and be honest, I don't think it'll be too hard. I haven't really reprogrammed a sketch like this. It'll probably take some time to figure it all out. But, I mean, here's what we got. We have pin 4 is a reset pin. Arduino has a reset pin automatically, so that's fine. Pin 8 is a hot air on and off. Now, it could be a switch in or it could be the switch out. I don't know. We'll have to test it. Pin 9, again, this is of the original chip. Pin 9 is a soldering station on and off. It could be, again, it could be this switch here, or it could be the chip sending the signal out to turn the iron on and off. I don't know. We'll have to scope it out and find out for sure. Pin 10 is the automatic switch on and off. That's this little guy here. Again, we have to find out if that's sending or receiving. Pin 19 is the fan out. Now, we do know that's output from the chip to the actual fan, so we do know that one. Pin 17 is the hot air fan out. It's not the Hall effect, so we can mark that off. We definitely know that's not the Hall effect. I thought it might be the Hall effect sensor, but later on we found the Hall effect sensor, so we know it's not the Hall effect sensor, so we mark that out. Pin 15 is the heating soldering iron element, out. Pin 14 is the hot air temperature potentiometer. That is this knob right here. So the chip reads this knob through that pin right there. And then the iron potentiometer, it reads it through that knob right there, through that pin. And then the iron thermocouple, the little temperature that's inside your soldering iron, the chip reads it through pin 12. And then let's see, the hot air heating element, it tells the hot air station to turn on and off through pin 11. And then pin 18 is the Hall effect sensor. That's the little magnet inside the holder. So we've got all that mapped out. The only thing we haven't got is pins 2 and 3, which I think is the digital readouts for the LEDs. Pins 5, 6, and 7, which are completely unknown right now. So that's what I'm working on. Trying to figure out what pins 5, 6, and 7 do. So I'm currently scoping those ones out. So as soon as we get them scoped out, and then what we need to do is we need to find out whether the switch is sending the signal to the chip on these pins, like pin 8, 9, etc., 8, 9, 10, or if the chip is sending the signal out from the chip to the actual circuit on those
that
switches.
_your_fan, BRB dog barking.
Okay, and so that's where we're at now. And then after we do that, we can start working on the sketch, and we'll start designing the sketch from scratch. And it'll probably take a couple streams before we get a sketch built, because, I mean, it'll be a pretty large sketch, assuming that we can get the readouts working. Honestly, I think the readouts are going to be the hardest thing, because I don't think that there's anything set for that display driver that I know of.
That _your_fan, back.
Okay. On the display driver for these readouts, I don't know if there's anything built for that. So I don't know. That's probably going to be the hardest thing, is getting the readouts to work. But anyway, so that's where we're at. Let me hit the tunes, get them turned back on again. By the way, welcome to the stream. Find us, and what are you up to today? Let's see here. Let's look at the scope again. So we are going to test out pin 5. 1, 2, 3, 4, 5. Okay, that looks like a signal to me. Pin 6 is just high. I think it just stays high. I don't know why. Nothing I do seems to bring it down. Hey, thanks for the subscription. I appreciate that. Okay, so
Dapper
it's just
King,
staying high.
Dapper King.
Dapper King, okay. Dapper King, got it. Okay, so that's pin 7. So pin 7 and pin 6 just are staying high. Nothing I do changes it. I'm going to disconnect the soldering iron. Nope, that ain't it.
That _your_fan, least I could do.
Oh, no
that
problem. I appreciate it.
_your_fan, the amount of work put into that machine vastly outweighs its worth. That _your_fan. Dapper King, I was on the science category. And I like engineering.
Awesome.
Sawyers, and now I am here.
Awesome. Well, normally I'm in Maker and what is it? Maker and Creative or Crafting. So I normally put this under Maker and Crafting, but because I was going to be messing with some Arduino, I figured, well, technically I haven't started with it, but I'm ready to start as soon as I get this finished. I said, well, I'm going to put it under Science and Technology. So Changed it up a little bit. I also stream games, and I stream Adobe stuff.
I stream too, and normally stream coding.
Oh, okay. Well, awesome. I like watching coding. What kind of coding? Just software, or like Python, or Arduino software, or what? C++, gaming, game coding. I'm trying to learn a bit of Python for I guess you call it like my primary language. Okay, so nothing seems to change pin 7. Everything I touch and nothing happens. Oh wait, I could lift it up out of the... Nope, nothing I touch changes it. So pin 7 stays high for no reason. Yeah, pin 7 just stays high. And I think so does 6. 6 just stays high for no reason also. At least no reason that I can determine.
Dapper King, Python and JavaScript.
Okay.
Right now making an app for movie streaming.
Oh, awesome. Okay, so I'm going to put down pin 7 and pin 6 is just staying high.
Place my dreams among the stars while I'm standing on the pavement.
That _ your _ fan. I guess one way to think of it is to keep track what pieces haven't been numbered yet. Dapper King, GTG. Got work.
Okay.
That _ your _ fan. Take care.
Without gravity to hold us down, together we'll lose sight of the ground.
Yeah, have a good one, Dapper King. Thank you for stopping by, and feel free to drop a like or a follow. I'll definitely be checking you out later. I don't know what times you stream, but if I can catch you on, I'll definitely have a look at it. I like coding, especially Python. I'm trying to learn it, so. So let me see, what else could that be if it's just staying high? I marked them both down as just staying high. So we got pin 5. 1, 2, 3, 4, 5. Now this is an interesting little thing right here. Let's zoom out a little bit on that. And it seems to be blinking. See now? Off. On. Off. Off. On.
I place my dreams among the stars while I'm standing on the pavement. Spinning around, lost and found, just trying to make a statement. Lift the weight off my shoulders.
That _ your _ fan, a pulse.
I know, huh? Okay, so let's turn a switch on. And let's see if I adjust the knob. Okay, let's change this from a rising edge to any edge.
Memories die out too hard. We were traveling the mountains just to find the loudest seas. We sat down by the fire, knowing we could aim higher, but we didn't know that yet. So if you want something to hold on to, gotta find it first. But here I am. 'Cause I've been
All right, let's try something a little bit different here.
waiting for the summer, knowing there's no
Let's get a second probe going.
'cause I am happy on this.
Oh, did I move a camera? No, I didn't move a camera. Let's see if this is I squared C.
I'm in a tropic club.
Try to. Haven't done this in a long time, so let's see if we can see if this is I squared C or anything else that we can identify. One. Excuse me.
We were traveling the mountains just to find the loudest seas. We sat down by the fire, knowing we could aim higher, but we didn't know that yet. So if you want something to hold on to, gotta find it first. But here I am, 'cause I've been laying under palm trees, waiting for the summer, knowing there's nowhere to go.
Nothing there.
'Cause I am happy on this island, wanna be my funland. I don't ever want to leave, I'm in a tropic club.
Sorry for the coughing. Oops. Oops, oops, oops.
Read hot, you're so patient, I would just heat it with a hair dryer. LOL.
Alright, so let's give it a signal. Okay, so we're not receiving anything under SPI. Try I squared C. Nothing under I squared C. RS320. Nothing under RS320. Parallel. Let's make it a little bit wider. Getting ones and zeros under parallel. Okay, let's go back to the other 2 pins. Right there. Nothing there. Am I sampling too fast?
That underscore your underscore fan, what chip is it?
Just a minute. Bouncing around too much. What can I capture this on? Let's see here. What can I capture it on? What can I capture it on? I can capture it on a falling edge, on a climbing edge. Okay, let me pop this off. Give my hand a break for a second. Okay, it is a... Just a second, I'll drop it in the chat.
Blonde hair, blue eyes, that'll make you faint. On side,
Control C. Control V. There we go. It's a Samsung chip. Turn this one off. Turn this one on.
That underscore your underscore fan, type.
No problem. You can get them on eBay fairly cheap. It's not a problem with the purchasing a chip. The only problem I think that we'd have would be programming the thing. That's the only problem that I see. And SWK, he was in here earlier. He may still be in here. I'm not sure. Yeah, he still is showing to be in the room. The SWK, he had a very good idea, which still is plausible. I haven't given up on my Arduino yet. The fact of the matter is, I already went in so far into the Arduino idea that I figure I might as well finish up with it as much as I can today. Because if I switched over to the SWK's idea today, it would pretty much just be me browsing the internet for a few hours.
That underscore your underscore fan, I didn't know you had to program an IC.
Oh yes. Yes, see, like this little guy right here, the Arduino, he'll have to be programmed too. Completely. The whole thing will have to be programmed. So SWK had a great idea. If I can find the program and I don't have to buy a programmer. See, let me explain something. This IC right here, let me take this out. This is an Arduino. Arduino is a prototyping board. The chip that the Arduino runs off of is an Atmega. That's this little guy right here. And this is an Atmega, what is this? 328. Okay? So in reality, all you're doing is you're using this chip. When you plug a wire in here, you're doing the exact same thing as attaching it to that pin right there. So let me get a pointer here. When you plug a wire into this pin right here, you're doing the exact same thing as attaching it to that pin right there on the deal. All the board does is it makes it simple to attach a wire from here to there. So you don't have to literally solder it every single time. You can just connect it here. Oh, that ain't where I want it at. I moved it over there. And so when you're done with this, what you really should do, most people don't, but what they should do is pop this chip off. You lift up underneath and you pop it off and you take the chip out and then you put it on a board like this one. And this is a proto board. And you put your chip in here and your chip fits right into these holes, and then you run a wire to your actual device that you're running. Like, let's say you have a knob. You have your control knob here, like this knob right here. You have this knob right here, and you just run your wire from pin 1 or whatever pin you had on your board, from that pin to the knob, to that pin to the knob, this pin to the light bulb, to, you know, whatever you're doing, these pins to your battery. And then when you're all done, when you turn your knob, it blinks the light or whatever you're having it do. And so that's what you're actually doing. But in order for the microchip to get it, buying new chips. The board costs you $10 and the microchips only cost you $1 or $2. And that's the way all microprocessors are used. Now, there are microchips. There's a difference between the two. There are microchips that you can buy that are non-programmable. But microprocessors are programmable.
That underscore your underscore fan, back.
Okay. Well, let's see here. Where was we? We was looking at this display, wasn't we? Soldering iron on. So where was we at? We was looking at, let's look at some other pins here. That one's doing nothing. That one's doing nothing. 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 Yeah, these have got to be the data. That's got to be data. That's all that can be. Okay, so I think we've gotten about all we can get out of the chip. Let me think, what else can we do here? Let's kick the power off. I'm trying to think. I think we got to pull the board off again. I can't think of anything else off of the chip itself that we can get right now. Pull this away. So let's rotate this around. And What did I do with my pliers? And it is 5 o'clock, so I got one more hour till dinner, guys. What is everybody else having for dinner this evening? Well, if it's evening here, it might not be evening where you guys are at.
Read hot, Chinese food.
Oh, okay. Splurging today, huh? You know what they say, evil splurges when the Chinese food does nothing. Well, I can't find my pliers for nothing now. Had them here this whole time. You requesting any songs today, Red Hat? Found them.
Read hot, you'll be sorry at the end of month.
That's how it works. They get you at the beginning.
Read hot, no. Thinking.
That's all you do is think. You think too much. Don't think, just act. Ban the torpedoes, full speed ahead. Alright, so off with these screws again. So
Read
more
hot,
likely than
my
not...
song choices are oldies.
Well, play them. It don't matter. If others don't care what your song choice is, then they can play their own. They all have request privileges. Everybody here can request a song. The only limits to the songs are I ask that it not be perverted. I ask that it not be really belligerent, you know, like you know, just offensive on purpose, you know. And really that's pretty much it, you know. It has basic things. It needs to actually be a song. It can't be, you know, just, you know, somebody's speech or something, you know. But it has to have more positive reviews than negative reviews. Stuff like that. I mean, I guess maybe not the chipmunks, you know. I don't care to hear chipmunks all the time, but I mean, other than that.
That underscore your underscore fan, SR.
The Da Vinci's Notebook. Huh. I don't think I know that one.
Declaration of my feelings for you.
Okay, so now we're looking at, let me see what we got here.
That underscore your underscore fan, former a cappella group.
Oh.
That no one else could
Hey, that got me going now. Hold on a second. I'll request one now. Now that you brought that up, just a second. You made me think now.
And our relationship's perfection.
Now you done went and stopped the whole stream now. Way to go, fan.
To our love's dissolution, mostly involving my unfaithfulness and lies.
That underscore your underscore fan.
Penitent admission of wrongdoing. Discovery of the depth of my affection. Regret over the lateness of my epiphany. Title of the song. Naive expression of love.
Where is it? Copy link address. That's what I want.
You are gone.
That underscore your underscore fan. This one song summed up boy band genre.
And rectify my wrongs. Repetition of the title of the song.
There we go.
Enumeration of my various transgressive actions.
There we go. I added an acapella too. How about that? You want to have a acapella off? We'll have an acapella off now. Now we'll see about that. Now we're having an acapella off. Yeah. Do. All right, so let's see what we got going on here.
Promise of my reformation. Reassurance that you still are foremost in my thoughts now. Need for instruction how to gain your trust again. Request for reconciliation.
Okay, so now let's see. We have. Can you look a chip up for me that you're fan? What I'd like you to look up is a.
Read hot. The glove has been tossed.
Yes, it has
That
been tossed.
underscore your underscore fan. Sure.
It is a T as in Tom, M as in Mike, 1628.
And rectify my wrongs. Repetition of the title of the
Let me go here.
acknowledgement that
That underscore your underscore fan.
increasingly desperate pleas for your return. Sorrow for my infidelity. Vain hope that my
Thank you.
sins are forgivable. Appeal for one more opportunity.
Yep, that's a serial clock.
Innocent crime response. Pray to my chosen deity. Modulation
I may be able to use that. I may be able to use that chip after all. I'll have to see what I can scope out of that with Arduino. All right, so what else are we looking at here? Oh, I need to make sure the camera's in focus. Just a second. Go here. Go there. Move the light around here. There's my song.
No treble.
I'm all about the bass, about the bass.
No treble.
I'm all about the bass, about the bass.
No treble.
I'm all about the bass, about the bass. Yeah, it's pretty clear she ain't no size 2, but girl can shake it like they supposed to do. She got that boom boom that all the boys chase, and all the right junk in all the right places. I see the magazines working at Photoshop. We know that it ain't real. Come on now, make it stop.
All right, so we got pin 1, 2, 3. So those are definitely going to the signals. I'm gonna unplug this. So it's now unplugged. Then we got this one. It's going to the controller, just as I said. So pin 1, 2, 3.
Then go ahead and move along. Because you know I'm all about the bass, no
3 was going nowhere.
about the bass, no treble. I'm all
Well, no wonder.
about the bass, no treble.
Pins
Bass about the bass. They're bringing booty back.
Go run and tell all
1, 2, 3. Pins 4,
just playing, girl, don't think
6, and 7 are not used.
You is perfect from the bottom to the top. You know my mama, she told me don't worry about
Let me look at that again. 1, 2, 3. Pin 4 is going nowhere. 6 and 7.
You know we don't want no stick figure silicone Barbie doll. No, we don't, no ma'am. So if that's what you're into, then go ahead and move along. Because I'm all about the bass, no treble. I'm all about the bass, no treble. I'm all about the bass, no treble. I'm all about the bass, I'm all about that bass,
No treble.
I'm all about that bass,
No treble.
I'm all about that bass,
No treble.
I'm all about that bass,
10, 9, and 8. Okay, so 10. I have that going to auto manual switch.
Hey y'all, thanks for watching. That's a really fun tune by Megan Trainor.
Okay, so 10 is the actual switch, so I can mark that down as the actual switch.
And we're happy to take a stab at it and have a good time. Be sure to check out homefreevocalband.com and Facebook for tour information. And please support us on
So 10 is the switch.
Subscribe. Boom. Bye guys.
For you, like a child.
Got it. Alright, 9 goes over here and it is connected to the actual switch for the soldering iron. That's in and that's in. And 8 is connected to the hot air station for the actual soldering iron. Hot air station input for the actual soldering iron. So here's what I did. Let's see if I got it on there. I did have the hot air 8 for the hot air station on off switch, and I had it for an IO. Well, let me see if I got it somewhere else. No, I don't have it somewhere else, but I had I/O. That means it could be an in or it could be an out. I don't know. In means it's coming from the switch going into the microcontroller. Out means it's coming out from the microcontroller and going out into like a transistor or off into something else. And I found out that it's coming from the switch into the microcontroller, so I marked out my O and I left the I. So that means that it's the hot air station switch, right? On-off switch input. So it's coming out from the switch into the microcontroller. So I marked all 3 of these. I marked the O's off and I left the N's on. The L means that when the signal is low on the scope, when the signal is low, that the switch is on. When the signal is low, the switch is on. When the signal is low, the switch is in auto mode. Not manual, but auto mode. So that's what I'm writing down. And don't mind the chicken scratch. Only one that's ever going to read that's me. I'm going to redo this and put it in typing real nice and neat later. But that's, that's the only one that's going to be reading that. I'm just showing you to see what I'm doing, how you reverse engineer something here. This is all old school. You could do this all on the computer, but rather than swinging back and forth on a keyboard, and see, my hands are all dirty now, so I don't want to have to get my keyboard dirty and everything. I can just do this all at once. So that should be all of the top.
Your underscore fan, SR.
SR? Oh, okay. So that should be all of the top pins, I think. I think all of the top pins are now done. Oh, let me see. 1, 2, 3. Okay. So all of the top pins, pins 1 through 10, have now been figured out. Let's go to pin 9. Okay, pin 11. So let's track down pin 11. I have pin 11 written down as hot air heating element. High is off. So let's go pin 11. We're tracking it down here. I'm going to zoom you in a little bit so you guys can get a little bit better of an idea of what I'm tracking here. Ooh, there's some doo-wop now. Oh yeah. Alright, so we got pin 11. That's him here. He jumps across this resistor. He runs down this track. Okay, he's on that resistor. Let me make sure I got that right there. Yep, that's him. On that resistor, he goes down, goes over here. He's on this resistor. Then he goes over here. He hops, let's see. Yep, that's him. He hops right across to there and he goes to this. I'm guessing that's a transistor because there's 3 pins there. So let's flip the board over and take a look at what we see. And I have that down as a hot air heating element. Okay, so it goes to an optocoupler. Close enough. Optocouplers are a form of a transistor in a way. So that's correct. So let's check mark these. Let's check mark this one. This one. This one. 11 is checked. 6 is good, 7's good, 4 is good. Let's see what else. 11's good. Let's go to 12 is iron thermocouple. So let's see, the iron thermocouple comes over here. Try to see, make sure I'm in the, yeah, I'm in frame, okay. So here. It runs down here and it goes. Whew, where's he go? They ran him underneath that pot. He connects right there. That capacitor. Then he runs over here. Back over to there? Run that again. He runs over here. Up, over, down. No, he doesn't. They're sneaky. He runs down to this resistor, then hops over runs up and then over here to this guy. Let me hold that right there. That goes to a different capacitor and this resistor right here. So let's hold at that capacitor. Let's run this resistor down. It goes from this resistor over here to this little guy here. And this resistor back over to this side to these three. Okay, that trim pot. So these three connections right here, 1, 2, 3. Splits again, and it goes to here. And that goes to the soldering iron. So that's correct. So that would be this one right here. That's 11. That would be 12. So that is correct. 12 is the heating element. A thermocouple. And now my pin gave out on me. There we go. Alright, so we got 12. Now let's go to number 13. Iron temp potentiometer. 13. It's 1, 2, 3. Okay, we just looked at that one. That goes right over here and straight over to there. And yeah, that goes to soldering iron potentiometer right here. So that one's correct. 14 is the hot air temperature potentiometer. That's going to be right down here. I see you. And that's going to be 14. So that goes here, here, here. It goes right there to that capacitor. And right there to the middle trim pot. So that's correct. That's 14. 15 is the iron element. So that's this trace right here. He goes up. Oops. He goes up. Where are you going? You go up, over, through that resistor. Oh, and up into that optocoupler. Okay, so that sounds good. 15 is correct. Let's see, we got 16 now. 16 runs down over this way, over here into, and what's it say it is? 16. Do I not have 16 written down? Okay, so I'm missing 16. So that's 15. Here's 16. It runs down this way over here. Yeah, it's 11, 12, 13, 14, 15, 16. So 16 I have not traced yet. Let's chase it down and see if we can figure out where it goes that way. It goes right here. Goes down to that capacitor.
That underscore your underscore fan. SR.
Alright, we're going to look up and behind there. Can't really see. Alright, we can't see behind that pot, so we're going to try something different. We got a voltmeter out. This should be it right here. So we'll test here to here. 11, 12, 13, 14, 15, 16. This should be it right here, but I must have something wrong. Because that should be a direct connection right there. How is that not a direct connection? What? Ah, that's why I was checking it. So it goes over here. They're sneaky. Alright, so that's a direct connection over here. Then we go to a resistor here. Alright, and then we follow this through. We go here. 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 We're still good here. Let's keep following the circuit. So we're still good here. Okay, now you're not able to see the voltmeter, so let's see if I can. Kind of hard to get everything in view. I'm working on a build to solve what we're dealing with right now. I'm not being able to see the voltmeter. There we go. Now let's see, where was I? I was here. And then I was here. And I was here. And here. And we still don't know where we're going. Let's back up to here. Never heard this song before. We're here.
That underscore your underscore fan. I love Bill words.
Oh, okay. So we go there and there. So what are you doing, you Trace?
Christina Lopez, dinner is ready.
Okay, baby, I'll wrap it up here in just a minute. They have so many jumpers on this circuit. Okay, it's going over here. And here. And here.
That underscore your underscore fan, dinner.
Oh yeah, I got dinner waiting on me now. That means I gotta wrap this up. Here. Aha, finally, I think I got it going somewhere. Did it go back over to here? It does. So it goes all the way back up here to the top of this chip. And that is back to this switch. So it has to do with the Hot-Air-Station. So 16 has something to do with the Hot-Air-Station. So I'm going to write down 16 Hot-Air-Station, and I'm going to pause there for dinner. Let me turn my voltmeter off so I don't discharge the battery. Okay, so as a recap, how far did we get? Well, we got
That underscore your underscore fan. Sounds good.
We got most of this. Let me turn the paper so it's readable to the camera. Let's turn it so it's readable to the camera, and the camera goes completely white out on it. Very nice camera. That's a smart camera for you there. So we got the chip figured out. All but 16. We haven't figured 16 out. I wrote it down, but apparently I messed it up because I didn't write it down here. So we haven't figured out 16. Everything else we've got figured out so far, and I've checked off everything but 16, 17, 18, and 19. So I need to check off 3 more pins, and then we can start doing programming. So our next stream, I'm trying to do this entire build on stream. Most of the builds that I start on stream, I'm trying to do completely on stream. So this one I'm doing on stream, unless you're in an entirely big hurry.
Hot. Looks like rewiring dad's pedals.
Well, as a matter of fact, if you've been paying attention,
That underscore your underscore fan.
if you've been paying attention, Red Hat, I don't think you have been. But if you've been paying attention and keeping up with the stream, you'll notice something is new in the projects page. But I don't think you've been keeping up with it, because I don't think you're quite keeping up with the stream like you're supposed to. But if you pay attention to the projects page, you'll notice there's something new in there. Anyway, so the next stream will be probably doing programming on this. So we'll probably have 1 or 2 streams that is probably nothing but programming in Arduino. And so we'll probably have the Arduino going, and a bunch of programming and scratching our heads and crying.
Hot. Oh, I forgot.
Crying out loud and stuff, because programming never goes right. Well, I'm not the best programmer. I used to be really good, but they've done a lot of updates to programming, so I have to get caught up on all the programming skills. My kung fu is not quite what it used to be, so I gotta get my kung fu back. So we gotta get our kung fu back, guys. But anyway, so we will catch you guys later, and the next stream will be on Friday, unless something bends or breaks, the water floods us out or something, you never know. And so until next Friday, we will be keeping the iron hot, and I'll probably be messing with my 3D printer and making out an order. So we'll see you guys later. I stream every Monday, Wednesday, and Friday. I'll probably be streaming this evening some gaming streams. In the evenings, I stream games, and in the afternoons, I stream electronics
That underscore
and
your
creatives.
underscore fan. Later.
So we'll catch you later. And if you missed any of today's broadcast, it will be on the VOD, by the way, that your fan, in case you was wondering. So we will see you all later, and have yourselves a good one. Thanks for enjoying the stream. Thanks for all the new followers and subscribers that you're fan. Thank you for the new subscription. And don't be afraid to use the emote, by the way, because you got an emote. So don't be afraid to throw that emote anywhere you want in any streams you want. It's a wrench and screwdriver. So throw the wrench in the works anywhere you want. So we'll see you all later. That goes for you too, Red Hat. Have yourselves a good one, and
That underscore your underscore fan.
there you go. We'll be seeing you all later.